So because they are both different packages, so there might not be any intersection between them.
Exactly, because they are talking about SPSS package and they are talking about SAS package. Did they mention they are giving some money from SPSS package and they are giving some money from SAS package? They are mentioning something like this. Tell me yes or no.
No, sir.
Did they mention? No, they have not mentioned that some money is providing from SPSS and some money is providing from SAS. Not. They are providing only either the money is providing from here or the money is providing from here. That's why. That's why the intersection probability of SPSS intersection SAS. This is actually phi set. The probability of phi 0. Okay, that's why it is coming as 0. That's why there is no need to write. Okay, and the last case that we are going to interested that last case is calculate probability of A complement intersection B complement. Tell me how to find. Bolo.
Union B the whole complement, De Morgan square.
What is De Morgan theorem? Bolo. What is De Morgan theorem? Probability of
one probability of A union B, that will be like a whole
complement?
of the power more complement. Yes, sir.
Exactly.
One
But what
minus
is this
A
about?
union
1
B.
minus
1 minus
A
P
union
A union B.
B. But you have calculated this value. Just put the value. You are having your final answer. So is it okay for everyone? I am asking to all. I am asking to all.
Yes, sir.
Yes, sir.
If there is
Yes, sir.
anyone who feels any difficulty, can ask me directly. There is no hesitation because you are learning. I am also learning. Okay, I am also learning from you. You are learning from me. So if there is anyone who feels any difficulty, can ask me directly. So 1 minus probability of union B. Just put the value. You are having your answer. Okay. So can I go for the next problem?
Yes.
Yes, sir.
Can I go for the next problem? Okay. That is another problem taken from the exercise. The computers of 6 faculty members in a certain like this. Check this problem. The computers of 6 faculty members in a certain department. This problem that I am talking about. The computers of 6 faculty members in a certain department are to be replaced. Okay. Two of the faculty members have selected the laptop machine and the other 4 have chosen the desktop machine. Okay, and suppose that only 2 of the setups can be done on a particular day. So first we are writing one by one. So how many faculties are there?
6.
Faculties.
6 faculty. Okay, 6 faculties are there actually. So therefore there are 6 computers are needed to be replaced. 6 computers need to be replaced. First one. It is mentioned that out of these 6 computers, 2 computers are laptop and 4 computers are desktop.
Stop, sir.
And they have mentioned in a certain day or in a particular day how many computers you can replace or you can repair.
Sir, 2.
2, sir. In a certain day, in a particular day, you can replace 2 computers. You can replace 2 computers. That data they have mentioned. So suppose I have 6 computers, so I can number them 1, 2, 3, 4, 5, and 6. Suppose the first 2 computers are my laptop model. This is my laptop model. This is my laptop model, and the remainings are desktop model. Desktop. Now I'm asking to everyone, can you tell me if I replace 2 computers in a particular day, what is the possible cases? Can anyone tell me?
15, sir.
2 laptops.
15.
No.
One
You tell me
laptop.
what type of cases I can expect.
So 1 2, 1 3, 1 4, 1 5, 1
Yes,
6,
exactly.
and then all.
2, 3.
I can write in this model, like if I am writing 1, 2, what is the meaning? That means I am going to replace faculty 1
One laptop
computer and faculty
and
2,
2 laptops at a time.
2 laptop. Faculty number 1 and faculty number 2 laptop I am going to replace. If I am writing 1, 3, the meaning is I am replacing
One laptop and one desktop.
and one. That means the third desktop I am replacing. Similarly, it will be 1 4, 1 5, and 1 6. Okay. Can I take 2, 1? Can
Yes,
I
sir.
take 2, 1? Yes or no?
No, sir.
No, sir.
No. Is anyone yes? Okay, we cannot take, because the meaning is, if you are taking 2, 1, that means you are replacing the second faculty laptop and first faculty laptop, but that is equivalent to this one. Am I correct?
First one.
That is
Yes, sir.
equivalent to this one. Therefore, you cannot take this case. This case you cannot take. So you have to take here, anyone?
The 2, 3.
3.
3.
2, 3, 2, 4, 5,
5,
and 2, 6.
6.
Okay, this you can take. Then, bolo, 3,
So 3, 4,
3,
3,
5,
5,
3, 5, and 3, 6.
3, 6.
Then,
4, 5,
4, 5.
6.
4,
and
6.
then
5,
5,
6.
5, 6.
Done, sir.
Now you tell me how many points are there?
So 15.
15. That's why they have written there are 15 likely possible cases. So if I give a set here, so each point becomes my, anyone? Each point right now becomes sample point, correct?
Yes, sir.
Sample point. Each point becomes sample point, and the total set becomes sample space. Okay, so each point becomes sample point, and the total set becomes my sample space. Now the question comes, what is the probability that both selected setup are from laptop computers? Bolo. Suppose A is the event.
1 and 2.
Sir,
So
one and
which type
two.
of points can be there?
So 1 and 2.
1 and 2 only.
1 and
The
2
first
percent.
one.
So what is the probability of A? Bolo.
So 1 by 15.
inside the event. Yes, number of points inside the event divided by total number of points inside the sample space. Is it okay for everyone? Please tell me.
Yes, sir.
Number of points inside the event divided by total number of event point. That is known as counting probability, and that is given in 2.3, but that is not in your syllabus. Just remember, if there are number of points, suppose anything, it may be 2, 3, whatever the may be, the points inside the event divided by total number of points in the event space or the sample space. So obviously here it is 1. That's why you are writing 1 by 16, 1 by 15. Okay, that is the value, 1 by 15. First answer is done. Now moving for the second one. What is the probability that both selected setups are desktop machine? Bolo.
Sir, 3, 4,
What
3,
is the
5,
probability
3,
that
4.
both selected machines are?
3, 4, 3, 5, 3, 6, 4, 5.
First to tell me,
3,
suppose
4,
the
3,
event is
5,
given
3,
with
6.
B. 3, 4, 3, 5,
3, 5, 3, 6. 4, 5.
4, 5, 4, 6.
4, 6. 5.
Can you think this in another way? Can you think this in another way? Bolo.
So decimal.
Can you think in another way? Like suppose there are 1, 2, 3, 4, 5, and 6. These are my laptop, and these are my desktop. So among these desktop, how many ways I can choose 2 desktop? Bolo. How many desktops are there?
4, C2.
4. So out of the 4 C2, and among these 6, how many types I can choose? Bolo. Among these 6 computers,
6 C2, sir.
2 computers I can choose in how many ways? 6 C2.
6 to 2.
So I can
6
write this
C2.
way. Na? So 4 C2 by 6 C2 becomes my probability of B. Am I correct? Please tell me yes or no.
Yes, sir.
Yes,
Yes,
I
sir.
write in this way. Now I am calculating. Dekho, is it coming the same thing? So you can write it is 4 factorial by 2 factorial into 4 factorial 2 factorial divided by 6 factorial. So can I write 6 factorial in this fashion? 6 into 5 into 4
6
factorial.
into 5 into 4 factorial. Yes, sir.
So 4 factorial cancelled, And suppose this 4 factorial, 2 factorial, 2 factorial cancelled. This 4 factorial can write in this way: 4 into
4
3 into 2
into 3
factorial.
into 2
Bolo.
factorial. Yes, sir.
This 2 factorial is cancelled. Okay. So
4
what
and
type of
6
data
will
you
be
have?
cancelled.
And you have
4
4
and 6
into
will be
3
cancelled.
by 6
By
into
6
5. What
into
is the
5.
value? 6 by 15. Am I correct?
Yes, sir.
6 by 15, no? Exactly. So you are getting the same number. So you have to think also different way, because here many things I have to select: 3, 4, 3, 5, 3, 6, 4, 5, 4, 6, and 5, 6. So many things you have to cover. But if you are writing 4C2 by 6C2, it becomes easy. So can anyone tell me, you have taken here 4C2, I can take 4P2? Why it is not possible? Can you tell me? Why I cannot take 4P2? Anyone?
This is arrangement. This is
Because
not like
you're selecting.
this is
Yeah.
arrangement.
करना है ना कि arrangement.
The logic is, if you are taking 3, 4, or if you are taking 4, 3, the meaning is equal. Am I correct? If you are taking
Yes,
3,
sir.
4,
Yes,
or you
sir.
are taking 4, 3, the meaning is equal, because you are taking the third computer and you are taking the fourth computer. That is equivalent to saying you are taking the fourth computer, you are taking the third computer. So therefore, it is not required. You only need this one. That's why 4C2 by 6C2 we are performing. So that thing you have to remember. Observe also that here we are, whenever we have written this type of thing, we have not taken 2, 1. We have not taken 2, 1. We have taken 2, 3, 2, 4 in this way. That's why in this case we are using 4C2 by 6C2. Okay. Next, then C. What is the probability that at least one selected setup is for a desktop computer? Bolo. At
So we'll
least,
subtract it with the
at least,
laptop one.
at least one desktop. What is the probability? That I am interested actually. What is the probability? Probability of at least one desktop. What is the problem? Bolo.
We'll take the complement and 1 minus the
4C1 plus 4C2 plus 4C3. That.
So can I think in this way? The event at least one desktop. What is the complementary event? Anyone?
So there will be no desktop there. Both are laptops.
Okay, both are laptop. This is the complementary event. Okay, so I can think probability of at least one laptop, that is actually 1 minus probability of both laptop. Correct? Can I think in this way?
Yes, sir.
Probability of at
Yes,
least
sir.
one desktop, that is actually 1 minus probability of both are laptop. But what is the probability? If I am thinking probability of both are laptop, bolo.
So 1 by
If I am
15.
thinking, exactly, it is given as 1 by 15. So ultimately it becomes 14 by 15. That is your answer. So here you notice one thing. You can also proceed this type of thing in this way, na? Like at least one desktop. Therefore, you have to write like 1, 2, 1, 3, 1, 4. 1, 3, 1, 4. Like in this way, you have to take like in that event space only except this point. You have to consider only all these points. Am I correct?
Yes, sir.
Except this point, you have to consider all the other points. But you observe, you can also get in the same number, 14 by 15. So you tell me, in that probability of B, whenever I am searching for part C problem, I am also getting the probability of at least one desktop is equal to, that is, I am giving by, if I count it 1, 2, 3, 4, 5, so I am getting 14. So I am writing actually 14 by 15. 14 by 15. Okay. So now you tell me one thing, extremely important. Everyone just carefully observe it. 14 by 15. So the number, the probability that I am getting from here and the probability that I am getting from here, both are same. But you observe,
Yes, sir.
so can anyone tell me which one is much laborious? Can you tell me?
So the second,
Which one?
like the second one, because we have already calculated the probability of laptops. Like we have just found one.
Exactly. So very good observation. See, here probability of at least one desktop, if you are going to calculate, then you have to write 1, 2, 3, 4, 5, 6, 7, 8, like in this you have to calculate. Okay. Now the case, suppose if you are using the complementary event, you have to simply consider this 1, 2 point. You simply perform the probability, 1 minus the probability, you are getting the answer. But if you are writing that at least one desktop corresponding event points if you are collecting, then you have to collect 1, 2, 3, 4, 5, 6. It's a laborious job. Now, suppose you have the case, suppose there are 1,000 cases. Is it possible for counting? Please tell me.
No, sir.
Is it possible for counting? No. Then you have to take what? You have to consider the complementary case. You have to consider the complementary case. Okay? You have to consider the complementary case. In that case, it will be much easier than this method. Is it okay for everyone? Whatever I'm trying to say, please tell me.
Yes,
Because
sir.
this technique is useful whenever you are going to study chapter 3, chapter 4, chapter 5 onwards. Because in that case, we are interested to find a probability, but if you are using that probability to find it, the value, it's a much boring job. It's a much boring job. But if you are using probability of A complement is equal to 1 minus probability of A. If you are using that type of logic, this calculation of probability is much easier, and 1 minus this gives you much easier and less time actually. So is it okay for everyone? Whatever I'm trying to say, please tell me.
Yes, sir.
Yes, sir.
Okay, fine.
Yes, sir.
So remember, it is extremely important. Remember, everyone remember. The last problem, that is, what is the probability that at least one computer of each type is chosen for setup? Bolo. At
So-
least one chosen from each type. Probability of, just a second, probability of at least
Sir, total
one model
minus
chosen.
in which both are laptops or
Present.
desks.
Both are present.
Okay. So therefore, I can think it actually in this model. 1 minus probability of means either
Laptops or
either full or, am I correct?
Yes, sir.
Either full laptop or full desktop. Am I correct? If I am considering this case, tell me which type of elements are there actually. Can I write this one? 1, 2. Can I write 3, 4? Can I write 3, 5? Bolo, bolo. 3, 6,
Yes, sir.
Yes, sir.
4, 5, and 4, 6, and 5, 6. These are the points. But observe, whenever you are taking only this point, you are dealing with either both a laptop or both a desktop. Just check it. Just check it. Then
Yes,
how
sir.
many points are there? How many points are there? Bolo.
So,
7.
7 points.
7 points are there. So therefore, the probability becomes 7 by 15.
7 by 15,
Correct?
sir.
7 by 15. So it becomes 1 minus 7 by, because at least one model is present. Therefore, it is 1 minus either full laptop or full desktop. That should be deleted. That is a complementary case. So 1 minus 7 by 15. Therefore, you are getting 8 by 15. Is it okay for everyone? Please tell me. Bolo, bolo.
Yes, sir.
Yes, sir.
Any doubt? Any doubt from any person? Bolo, any student? Bolo. Any doubt from any student? Bolo, pucho. Sulagna, Abhash, Priyanshu,
No, sir, no
Abhijit, Saurabh,
No, sir.
Yuvraj. I am asking to everyone, not a single. I am asking to all. Okay.
Yes,
So I can assume all of you understood. I can assume that.
yes, sir.
So
Yes, sir.
I am going for the next problem. Suppose this problem I have taken just for the case. First, I have done this problem from the question is written here. Just come to here 0.4 and 0.58. No? So the problem I have taken from here actually. Okay. This problem. First, we are reading this problem. There is problem number 25. First, we read the problem carefully. Okay. The three most popular options the three most popular options on a certain type of new car are built in. Abhi, like nowadays, new cars are coming now. So there are different types of technologies are involved inside a new car. All of you know this. Suppose in one car there is a GPS system. Okay, in one car there is a sunroof system. That means the top sunroof system. And suppose in a one car automatic transmission system. So there are three types of things they are talking about. The first thing is that first event is that the three most popular options on a certain type of new car are built in GPS system, okay, GPS system, the sunroof system, and the automatic transmission system. So three things they are talking about. If 40% of all purchasers request A, that means 45% customers, 40% customers, they are demanding or they are claiming for GPS type of cards. I mean the cards that inside the card GPS system is there actually. Suppose 55% buyers or the customers, they are claiming for the car which has sunroof type of thing, sunroof. Okay, so there are 55% customers or the buyers who are claiming for sunroof type of model. Those cars have sunroof actually. All of you have seen sunroof type of model car, hopefully. And there are 70 and there are how many? 63% request. How many? 40% request on A and 55% on B, 70% on C. 70% request for C. That means 70% request for automatic transmission. That type of cars the buyers are claiming. 70% request are coming for automatic transmission. And 63% request A or B, 77% request A or C, 80% request B or C, and 85% request for A or B or C actually. Now they are claiming determine the following probabilities. So they have given some certain data they have given. So they have given some values like probability of A, probability of B, probability of C, probability of A union B, union C, like this type of thing they have given here. How I proceed? See here. So probability of A intersection B, how to calculate this type of value actually? Probability of A union B that they have calculated in this model actually, because you observe where I am left here. Here. So whenever they are writing 63% request A or B, what is the meaning? Bolo, anyone? What is the meaning of 63% A union?
They choose A
I
or B
mentioned
or both.
yeah, exactly. I mentioned na, A union B means A or B. A
B.
intersection B means A and B. Am I correct?
Yes, sir.
A
Yes, sir.
intersection B means A and B. A union B means A or B. Just remember these two lines very carefully. A intersection B. That means A and B. And A union B. That means A or B. So this line you just remember. It is important. Okay. Here I have done. So first thing. So on that basis, so it is given actually probability of A plus probability of B, that is already given. Probability of A union B already given, because probability of A union B they have given by the data, that is probability of A union B is given by 0.63. Okay, probability of A union B that is given by 0.63. Okay, similarly probability of B union C they have given some data. Probability of A union C also they have given by some data, and also it is given probability of A, probability of B, and probability of C, that is given. This is also provided, and the last thing they have provided, that is 85% request A or B or C. That means probability of anyone?
A union B union C.
0.85. So this data they have provided to us actually. Okay. So now they are asking some calculation part actually. So first we are going to calculate something actually. On that basis we are doing it everything. Okay. So first in this case we are interested to calculate probability of A intersection B. Can you calculate the value of probability of A intersection B from the given data? Bolo. Can you calculate
So from the
probability of A
formula.
intersection B? Exactly.
Yes, sir.
By probability of A plus probability of B minus probability
Minus
of
union, sir.
A union B. So A, B and A union B all is known to us because I mentioned na, A, B, A union B known to us. You just add these two things minus 0.63. You are having the number A intersection B. Similarly, can you find the number A intersection C and
So B intersection C.
C? Huh? Can you calculate these two values also? Like
Yes, sir.
this? All of you understood, na student? I am asking to all. I am asking to all. Can you find the
Yes,
number?
sir.
Probability of AB,
Yes, sir.
probability AC, probability of BC? I hope you can find. Okay. So that type of thing I have already calculated here. Probability of AB is equal to this, probability of AC is equal to this, and probability of BC is equal to 0.45. Okay. Now we are interested to calculate probability of A intersection B intersection C. Bolo. How to calculate probability of A, B, C? Bolo. How to calculate
So
this one?
probability of A plus probability of B plus probability of C and minus and then the formula exactly, sir.
Can I write this model? Just tell me.
Minus the intersection, sir. And plus time the intersection of all.
Correct? So I have to calculate this one. So I can take all this part,
To the left side.
you know. Okay. So I can take all these parts in this left hand side. Am I correct?
Yes, sir. Yes, sir.
Tell me exactly. So from this point of view, I can find the value of ABC.
Sir.
I can easily calculate because all this known because AB, BC, AC. From where I can get the number? Bolo. From where I can get the number of AB, BC, AC? Bolo.
From the question itself, it's mentioned.
No. From here. Correct? Because in the question it is mentioned A union B. A union B, A union C is mentioned. It is not mentioned A intersection B. A
Yes, sir.
intersection B you have to calculate. A intersection C you have to calculate. And B intersection C you have to calculate. Is it fine? Please tell me.
Yes, sir.
Yes,
Exactly. So you have to calculate the numbers, probability of AB, probability of AC, probability of BC from the data that is given. Because in the data they have already given probability of A union B, probability of B union C, probability of A union C, probability of A union B union C, probability of A, probability B, probability C. That data they have only provided, but you have to calculate probability of AB, probability of AC, probability of BC. That value you have to calculate from the given data. And after finding this data, you have to apply in this particular example. That I have calculated probability of AB, probability of BC, probability of AC, and ABC. That you have this, just subtract, addition something, you are getting the number probability of A intersection B intersection C. So, Bolo, is it fine for everyone right now?
Yes, sir.
Or any doubt? Bolo, pucho.
Sir.
Okay. Ritobhoto is there. Is it fine, Ritobhoto? He is not joining. Okay, Ritoban and Priyangshu. Is it
Yes,
fine?
sir. Clear.
Okay.
That's fine.
Okay. So probability of ABC, actually, that you can easily calculate from this point of view. Actually, now they are asking some questions. On that basis, we are just trying to find some data. Actually, okay. See. So that is the Venn diagram, is how we are going to write these things actually, that what is the intersection portion, what is the joint portion, what is the probability of A intersection B, what is probability of E, what is probability of B. All the data I have written here actually in this nice Venn diagram. Actually, you just check it actually, just like 0.05. How it is coming? 0.05 means it is given in the data set actually. From this set actually. This is your this set total thing is this, like I have calculated the data set, you can easily got it from here, the Venn diagram. I have drawn it here actually. Now, the case they have asked, that is the first question they have asked. And you can observe the try to drawing a Venn diagram and labeling all the regions actually. Now the first question, the next purchase will request at least one of the three options. The next purchase will request at least one of the three options. Tell me how to proceed. Bolo. The next
probability
purchase
of
will
A
request at least,
Unions.
exactly, at least, whenever I am writing the term at least, be careful. Whenever I'm writing the term at least, that means or. That is or term is involved. Okay. Whenever I'm writing at least, that means or term is involved. So either A or means what? Union, B, union, C. That probability you have to calculate. That probability already it is given. So you can simply have 0.85 because you observe in the question they have mentioned 85%. Observe 85% request for A or B or C. Therefore, probability of A union B union C becomes 0.85. Okay. Then the next purchase will select none of the three options below. What will be the answer? None of the three options they will select. What is the meaning?
So complement of probability of A union B union C.
Complement of A union B union C, total complement, correct?
Yes.
A union B union C, total complement. Or also you can think in this model, probability of A complement intersection B complement intersection C complement. Also you can think in this model actually. So whatever the number, you can write the actual probability of A union B union C. Okay. You are having the number 0.85. So 1 minus 0.85. We have 0.15. That number we have. That is what is the C question? The next purchaser will request only an automatic transmission and not either of the two options below. Automatic transmission the person will request, but not the other two options below. What is the probability? Anyone? The person will request only for automatic transmission, but not for the GPRS. Not
Exactly one. Like only the
not for
automatic
the
one.
Probability of C and complement of probability and complement of probability B.
Means the person is interested to purchase only transmission, automatic transmission, but not the GPS, not sunroof. So can I think this matter in this way? Can I think this matter in this way? Please tell me. Can I think the person is not interested for GPRS, not interested for sunroof, but interested for automatic transmission? Can I think the probability in this fashion? Please tell me yes or no. Bolo.
Yes, sir.
Services में AI है sir.
हाँ बोलो बोलो. Tell me, पूछो. You can ask. पूछो.
No, sir, it was a background noise from someone else.
Okay. So am I correct? A complement intersection B complement intersection C. That means I can think in this way, na? That means the person is not taking GPRS, not taking sunroof, only taking automatic transmission. Am I correct? Please tell me.
Yes, sir.
Follow.
Yes, sir.
Yes, sir.
So that probability I have to consider. So think how I am thinking, that is important, because here what they have mentioned. So tell me one thing. A is an event, A complement is the complementary event. So if I am telling the person is interested for the GPS model, okay? So what is A complement representing? Bolo? If the person is interested for GPS model, that means not interested for GPS. Am I correct? If it is B
Yes, sir.
and B complement, if B is my sunroof model, so what is B complement? Not sunroof. Okay, this is the thing. Why I am giving intersection? Because all the three things will happen together. Therefore, A complement intersection B complement intersection C. Now you see what I have done here. So that is the next part. Will select none of the three options. That is okay, but at least one. Only the automatic transmission. So from the Venn diagram, actually simply 0.22, because I am the Venn diagram, I have done this, only this portion you can observe. Only this, because this part I am also needed actually, because from the Venn diagram I have calculated, because I have this. So only this is my A, this is my B, and this is my C. Can you tell me A complement intersection, B complement intersection C? What is my region? I have done this previously. Bolo. I have done this previously. Bolo. Anyone?
At the lower portion of
The lower portion of the C.
Am I correct? I have done this in the last previous class, I think.
Yes, sir.
This is the portion. What it comes? I can write it actually probability of C minus bolo. Probability of AC.
Section
Tell me. Probability of
section C.
AB plus. Am I correct? Bolo.
Yes.
Probability
Yes,
of
sir.
A complement. In the last class, just check the copy. In the last class, I have explained it very nicely.
Probability of
complement-
AC minus probability of BC.
हाँ, बोलो, probability of BC exactly. Probability of BC.
Second वाला BC होगा. Third.
अब सही है.
Yes, sir.
Yes, sir.
हाँ, probability of C minus probability of AC minus probability of BC plus probability of AC that I have discussed in the last class. Just check the copy in the last class. How I am coming to this conclusion? Just check the copy. As a probability of A complement, probability of B complement, and C that is given by this. You just perform the data. You are having 0.22. Okay, that thing I have done here. What I have done? This C problem.
13 question number E we did this.
हाँ बोलो. Tell me, students. Tell me. 0.22. Tell me, student. Please tell me whatever you are asking to me. And the last case, that is D. The next purchaser will select exactly one of these three options. The next purchaser will select exactly one of these three options. Bolo. Exactly one of these three options. What is the probability? Tell me. How to come? Bolo. I have done this here. From the Venn diagram. That means bolo. Exactly one of these three options. What is the meaning? Anyone? Exactly one of these three
Probability
options.
of-
That means, can I consider this in this particular model? Bolo.
Yes, sir.
Am I correct? Please tell me yes or no. Bolo. Only these portions
sir.
are deleted.
yes, sir.
So therefore, I can think in this model, probability of, for the first case I am writing A intersection B complement intersection C complement, okay? Then giving the plus or union, whatever you are telling, plus. Then I am writing A complement intersection B intersection C complement, okay? Plus. The last case is that is whatever writing
A complement
A
B
complement intersection B complement intersection C. Right. So now you tell me the events this and this, are they pairwise disjoint? Are they pairwise disjoint? Please tell me.
Yes, sir.
So if their pairwise disjoint, then from axiom number 3, what can we write? Bolo? If they are pairwise disjoint, then we can
union.
just simply sum of these type of things. Am I correct?
Union is
Probability
also-
of this plus probability of this plus probability of this. Okay, that thing you have to calculate. That thing I have done here. See. 0.05, 0.08, and 0.22. Because in last case you have already calculated 0.22. So 0.05, 0.08, and 0.22. So ultimately you are having 0.35. So is it okay for everyone? Well, is it okay
Yes,
for
sir.
everyone?
Yes, sir.
Priyanshu, Abhash, Saurabh, Ritabroto, Abhijit.
Yes, sir. Hi,
Bolo.
sir.
So any doubt can ask me. Pucho. So you have to draw the
No,
Venn
sir.
diagram in your exam hall very nicely. Okay. It is extremely important on how I discuss the problems. If you are facing any difficulty, just go to the Venn diagram and you draw the figure for draw the diagram. It will help you to cover the problem actually. Okay. So okay. So now tell me, should I stop here or I should go further? Tell me. It is choice is yours actually. Tell
Stop
me.
here.
We'll
Okay.
study in next class.
Okay, fine. So now
Sir.
right now just give the attendance. Tell me. Give the attendance. So I have back-to-back class today actually. So just give the attendance. Login. Login. So is it fine in the class or anything going wrong? Bolo.
Fine, sir.
Fine, sir.
Fine, sir.
Fine. Okay, okay. Okay, so mark attendance and select all. Bolo. 001 Abhijit Kumar.
Yes, sir.
031